Here we're going to look at oxidising agents and reducing agents and recognising them from looking at equations. The equation we're going to look at is the equation for the reaction between zinc and hydrochloric acid. Let's use zinc chloride and hydrogen. Now, when figuring out what's going on in a redox reaction, the first thing you should be doing is looking at what are the oxidation states of each atom within each substance. Now, the oxidation state of the zinc here is an uncombined element, so the oxidation state is 0. The oxidation state of the zinc in zinc chloride. Well, the chlorine has got an oxidation state of -1, because chlorine always has an oxidation state of -1 unless bonded to oxygen or fluorine. So we've got 2 times -1, which is -2. And for the sum of the oxidation states equals 0. Zinc's oxidation state must be +2. The hydrogen has got a fixed oxidation state of +1 when in compounds, except when bonded to metals. That means that the chlorine has got an oxidation state of -1. So you can see the oxidation state of the chlorine hasn't actually changed in this reaction. The oxidation state of hydrogen in H2, well, it's an uncombined element, so the oxidation state there is 0. So we can see from this reaction that the oxidation state of zinc has increased from 0 in zinc to +2 in zinc chloride. So the oxidation state has increased. And when oxidation state increases, that means you have an oxidation. So the zinc is the atom being oxidised. The zinc's oxidised to zinc chloride. The oxidation state of hydrogen has decreased from +1 in HCl to 0 in hydrogen. And when oxidation state decreases, then we have a reduction. Now, there are 2 really important concepts that you need to remember when doing redox reactions, looking at redox reactions. Now, in terms of what the oxidising agent and reducing agent is, well, what has actually caused this zinc to be oxidised? Well, it's the HCl. Oxidising agents will always contain an atom where the oxidation state has decreased. So you can see there that the hydrogen's oxidation state has decreased, so this here is an oxidising agent. So the HCl causes the Zn to be oxidised, and therefore HCl is my oxidising agent. Okay, and they're themselves reduced. Or I should really say that an atom within the oxidising agent, one of the atom's oxidation states is always reduced. So that must mean then that the zinc causes the HCl to be reduced. Therefore, zinc is my reducing agent. And reducing agents, they are themselves oxidised. So typical oxidising agents are usually non-metals. So oxidising agents tend to be non-metals like fluorine, oxygen, chlorine, or oxidising agents may be species which has an atom with a very high oxidation state. So something like you should know from the organic, the dichromate iron. That's an oxidising agent because it's got an atom within it which has got a very high oxidation state. Another one would include something like permanganate ions. Again, very good oxidising agents because it's got an atom within it which has got a very high oxidation number. And as I did say from my definition, when these act as oxidising agents, one of these atoms, which is actually the chromium, is the oxidation number does reduce. When we're looking at reducing agents tend to be metals or hydrogen. So again, zinc, sodium, nickel, they are metals. They tend to lose electrons, so they tend to be good reducing agents. And also hydrogen is an excellent reducing agent as well. So that is how you can recognise oxidising agents and reducing agents. I said my advice is look at the equation, assign oxidation states, and then follow the guidance there in the video.